This is the solution video for question 27 from part B of the 2019 ECAA paper. In this question, we're told about a test which contains 20 questions. 10 of the questions score 1 for a correct answer and 0 otherwise. The other 10 questions score 2 for a correct answer and 0 otherwise. We're then told a student's mean score per question, so one specific student's mean is 1.15, and the same student's modal number of marks per question is 1. Given this information, we're asked for how many questions did the student score 0, and we're given 5 possible options: 3, 4, 5, 6 and 7. The key to this question is notating effectively the information we're given. So to that means we're going to introduce some notation A and B. A is a number of correct answers that the student gives to 1 markers, and B is the number of correct answers that the student gives to 2 markers. So in terms of A and B, what does our information mean here? A student's mean score per question is 1.15. So that means that A plus 2B over 20 is 1.15, because for each A we only get 1 mark, but for every question we're counting B we get 2 marks, so we need A plus 2B over the total number of questions. And let's times both sides by 20 to get A plus 2B equals 23, which is now quite a nice, useful bit of information. What else do we know? Well, we've got to convert this piece of information to something algebraic. The student's modal number of marks per question is 1. So that means that the number of 1 markers that the student gets right is bigger than the number of 2 markers. And it also means the number of 1 markers is which are right is bigger than the number of questions wrong in the whole paper. So A is bigger than 20 minus A minus B. So now let's try, if we can find the values of A and B such that all this holds, we're done. So from this we see A's going to have to be pretty big. So let's start with A equals 10, which is the biggest it could be, and work our way down. So A equals 10. Well, that, if this was true, would imply 2B is 13, which is nonsense because B is a integer, and 2 times an integer can't give an odd number. So this can't be the case we want. So let's try A equals 9. Well, A is 9. Well, that implies 2B equals 13 if this is true. 14, sorry, if this is true. It implies B is 7, so that's good. So we have A greater than B2, and 20 minus 9 minus 7 is clearly going to be small enough to be less than A, which is 9. So we've got both these conditions, we've got everything we want, so this is the case we want. So we know A is 9 and B is 7, so we just need to work out 20 minus A minus B for our answer here. 20 minus 9 minus 7 is 4, that matches option B, and so our answer is